I will now describe the basins located in compressional tectonic setting. I will start by talking about active margin. An active margin, or subduction zone, is a convergent plate boundary where one tectonic plate moves under another and sinks into the mantle as the plate converge. Plates induce both oceanic crust and continental crust. Stable subduction zones involve the oceanic lithosphere of one plate sliding beneath the continental lithosphere or oceanic lithosphere or another plate due to the higher density of the oceanic lithosphere. That is, the subducted lithosphere is always oceanic due to the fact that oceanic lithosphere is denser than continental lithosphere. The overriding lithosphere may or may not be oceanic. Different features can be found in active margins. Associated structural feature of oceanic trench is accretionary prism. Accretionary prism has a wedge shape forming as a result of compressive forces. Sediment accumulation on the sinking crust are scrapped in ocean trench because of downgoing plate. In the Barbados, oil has been discovered in accretionary prism. Subduction zones generate zones of accumulation of sediments in the trench and on overriding plates. It includes forearc and backarc basins. Forearc basins form between the volcanic arc and the trench. Volcanic arc and accretionary prism border the edge of the forearc basin. Dimension of forearc basin depends on the arc-trench gap. Continental margin or oceanic crust may form the base of the forearc basin. Concerning its capacity to accumulate sediments, rate of subsidence of forearc basin is controlled by sediment loading. On sedimentological aspects, forearc basin essentially has volcanic arc as provenance of the sediments, and change in depositional environment may occur. The depositional environments may evolve from deepwater deposits, shallow marine deposits, deltaic deposits, and fluvial deposits on top. They have low petroleum potential and are difficult to explore. However, few discoveries have been done in those areas. Backarc basins are formed landwards of the volcanic arc. They are characterized by an extensional tectonic regime and are not present in all the active margins. Discoveries have been done in those areas in Indonesia. A fall-length thrust belt is a series of mountainous foothills adjacent to an orogenic belt, which form due to contractional tectonics. Fall-length thrust belts commonly form adjacent to a major orogeny as the formation propagates outward. They usually comprise both faults and thrust faults, commonly interrelated. Those areas can hold excellent petroleum systems. Reservoir, silts, and source rock types are diverse. However, the traps are thrust anticlines. It can also be salt domes. A foreland basin is a structural basin that develops adjacent and parallel to a mountain belt. Foreland basins form because of the immense mass created by crustal thickening associated with the evolution of a mountain belt, causes the lithosphere to bend by a process known as lithospheric flexure. The width and depth of the foreland basins are determined by the flexural rigidity of the underlying lithosphere and the characteristics of the mountain belt. The foreland basin receives sediments that are eroded of the adjacent mountain belts, filling with thick sedimentary successions that thin away from the source. Foreland basins are very prospective areas. Source rocks, reservoir silts, and traps are diverse.